Perfect. Thanks, Aaron.
How do you like look at an application and know, okay, this is going to be good for robotic welding or not? What are those factors that drive it one way or another? There's a lot of this manually done.
Yeah. Yeah, so we touched on that just a tiny bit early, but we can go into a little more detail there. Components coming into the weld cell are hugely important. So if you're consistent process upstream and you're loading in consistent pieces into the weldment and you're not having to heat and beat and grind and pound, that's obviously a good place to start. If you see guys with clamps and pry bars and torches and trying to get things fit so they can get it tacked together and then come back and weld it, that's not going to be a good robotic application. Consistent joint fit up is crucial. When I look at robot projects in general, I tend to look at weld content on the part and what type of cell and how do you want to set it up, right? So if you have a million parts that only have 2 inches of weld on them, that's a different system than if you have 20 parts that have a ton of weld content on them. So generally, I like to start new customers. Some listen to this, some don't. I like to start with the easier, right? Let's crawl, walk, run. Let's find some small pieces. Let's figure out what type of work cell I can justify. Let's work together in that process. So I generally do like a spreadsheet cycle time estimate. Like if I know how many welds, how many starts and stops, I can assume that I'm going to want to do some touch sensing on a percentage of the joints in the weldment. I can then lay out a little roadmap of, okay, these 8 parts are going to utilize this cell at 80% or whatever the number is. Well, that's a pretty good starting point to get onto the budget conversation. Now I look at those 8 parts and I say, of those 8 parts, how many of them fit together real well? How many of them do we have good gap control, and can we control the weldment itself? And then just start working from there. But really the factors are amount of wire in the joint and how well the part fits. And if the parts fit good, but they're not using fixturing today because they don't have to, because they fit so well, like some people are using tab and slot. And they're laser cut parts that are tabbed and slotted, and they're barely using fixtures because the tabs and slots hold everything together the way they need them to. I mean, that's a great starting point because you know those components coming into that cell are going to fit up. We go to one thing that we're seeing right now, I'm seeing at least in a lot of my customers that have been welding for 20 plus years, they've got the welding perfected, but the way that they've done it for a long time has been to throw an operator in front of that weld cell. Well, I have plenty of customers out there right now that can't run their weld cells because they can't find enough operators. So we're looking at robotically loading weld cells, robotically loading fixtures, or robotically loading tacking stations, tacking with the robot, taking a material handling robot, and then loading a finish weld station. That's more and more prevalent in the last 2 years. There's some major manufacturers within the upper Midwest that are investing heavily into that type of process. But in that scenario, tab and slot doesn't always work very well, because if you're taking a material handling robot and you're trying to fit a tab and a slot, and there's any variation, any burr, an operator that sees that can address that real easily. So a robot trying to stick that tab into that slot that's got a burr on it, it doesn't fit, now you're crashing robots, it's no good. So we're actually going to the extent of removing a lot of the tabs and slots and doing some light tack fixturing that allows us to go in and get things tacked to the self-supporting state and then load them into a finish weld cell, because that's another big factor of robotic welding is how can I hold the part and also weld it, right? Because if you're trying to hold datum points and joints in the right location, you may be blocking torch access to that space. So kind kind of rambled a lot there, but that's sort of break it down to what do the parts look like coming into the cell, and are they using fixturing today or not? Obviously, the more weld content, the better the utilization of the cell. However, a lot of short welds, so a bigger part with a lot of shorter welds, you're going to likely see the biggest gain in throughput, because that's where the operator, if a manual welder is welding within his little bubble here, he's probably barely lifting his hood up, he's doing his welds, and he's moving his part on and getting the next one. But if he's climbing all over a bigger part, you got a lot of inefficiency. He does one weld over here that's 6 inches, he flips his hood, he walks over here, he moves, he grabs a drink of water, he talks to his buddy over there, he flips his hood down. Not very efficient. That's where the robot, you're just, it's way, way better.